Assalamualaikum and a very good day to our respected lecturer, Prof. Madya S.R. Dr. Nur Aziam binti Muhammad Yuswan. We are from Group 2 and today we will present our case study for BQS552 Construction Technology 4, which focuses on earthwork. In this presentation, we will discuss two construction projects, the earthwork method used, the challenges faced during the construction and the solutions implemented. Before we begin, let me introduce our team members. I am Adi Usaini and together with Muhammad Fakri, Raya Atta, Muhammad Fahmi and Sharima Shaidan, we work together to complete this case study. Now, let's move on to the presentation. These are the topics that we will cover today. First, we will give an introduction to earthwork. Next, we will present an overview of our two case studies followed by the construction method used. After that, we will discuss the challenges and solutions, compare both projects, and finally conclude our presentation. First, let's understand what earthwork is. Earthwork is one of the most important activities at the beginning of a construction project. It involves excavation, cutting, filling, grading, and compaction to prepare the land before construction begins. The main purpose of earthwork is to create a stable and level foundation that can safely support buildings and infrastructure. Proper earthwork also helps improve construction efficiency, ensures safety, and reduce environmental impacts such as soil erosion and sedimentation.
So I will be presenting about the first case study, which is the Merdeka 118, which is the tallest building in Malaysia and Southeast Asia. The project is located at Jalan Hang Jebat, Kuala Lumpur, and was developed by PNB Merdeka Ventures, Sdn Bhd. Construction started in 2014. Since the building has a very deep basement, a large amount of earthwork had to be completed before the foundation work could begin. The construction started with site clearance and ground leveling. After that, the contiguous bore pile, which is the CBP, were installed as retaining walls around the excavation area. Then the contractor carried out the top-down excavation in stages. As the excavation become deeper and deeper, ground anchors and steel struts were installed to keep the retaining wall stable. And finally, the ground was compacted before the foundation work started. So moving on to the materials and equipment that is used in the project Merdeka 118. So the main materials include contiguous bore piles, CBP, which acted as temporary retaining walls during the excavation. Maintenance slurry was used to prevent the boreholes from collapsing during the drilling. And besides that, ground anchor and steel struts were installed to provide extra support to the retaining walls. For the equipment, the project used bower drilling rigs to install the bore pile. Crawler cranes were used to break the hard limestone. Long reach excavator carried out the excavation work, while tipper trucks transport the excavated soil earlier. And lastly, the vibratory rollers were used to compact the ground before the foundation work. To make sure that the foundation was safe, several tests were carried out. The first one was the O-cell test, which checked the load capacity of the bore pile. Next was the bidirectional load test, which measured the pile performance. And the project also used the sonic logging test to check the quality of the concrete piles. However, despite all these tests, the project faced several challenges. So the first one is the hard limestone and uneven ground condition, which make the drilling more and more difficult. The excavation was also carried out very close to the MRT tunnel, so any ground movement had to be controlled carefully. Besides that, the project also faced groundwater seepage, limited space, and heavy traffic because the site is located in the center of the city. So to overcome the problems, the contractor used the heavy duty drilling equipment to break the hard limestone. Next, the bentonite slurry, steel struts, and the controlled dewatering system were also used to keep the excavation stable and safe. Even though the solutions increased the project cost because of the specialized equipment and continuous monitoring, they were necessary to ensure safety. So overall, these methods were effective because they protected the nearby MRT tunnel, and controlled groundwater, and allowed the earthwork to be completed safely and successfully. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fakri bin Azmi, and I will be presenting the case study 2, which is the Tun Razak Exchange TRX project. TRX is located in Kuala Lumpur and was developed as Malaysia's international financial districts. It is a large mixed-use development covering approximately 70 acres, consisting of office towers, residential buildings, hotels, retail facilities, and supporting infrastructure. Construction was started in 2012 under TRX City's neighborhood. Before the main buildings could be constructed, extensive earthwork activities were carried out. These include site clearance, bulk excavations, rock excavations, secant pile, wall construction, grouting works, piling works, and continuous monitoring to ensure the stability and safety of the construction site. During the earthwork stage, several important materials and heavy equipment were used. The main materials include high-strength concrete, which was used for the secant pile walls and foundation piles. Grouting materials were injected into the ground to improve soil stability and reduce groundwater seepage. Selected fill materials and crushed aggregates were used for backfilling and ground preparation, while geotextile fabric was installed to improve drainage and strengthen the soil. The project also required various heavy equipment. Hydraulic excavator carried out bulk excavations, while dump trucks transported excavated soil and rock. Hydraulic breakers were used to break hard limestones, piling rigs installed the deep foundation piles, and cranes lifted heavy materials and equipment throughout the construction process. Next one is testing and challenge. Several testings and monitoring activities were conducted to ensure that the ground conditions met engineering requirements. This included soil investigations, which identify the soil and rock conditions before construction, and the standard penetration test, or SPT, which measure the strength and bearing capacity of the soil. In addition, groundwater monitoring and settlement monitoring were carried out continuously to detect any ground movement during excavation. Despite these measures, the project faced several challenges. The excavation was carried out in a busy city center with limited working space. The site also contained hard limestone formations, groundwater seepage, and deep excavation works, making construction more complex and requiring careful planning. And the last one is solutions, cost, and effectiveness. To overcome this challenge, several engineering solutions were implemented. The project used secant piles walls to stabilize the excavation, while grouting works improved weak ground conditions. A dewatering system was installed to control groundwater, and continuous monitoring ensured that the excavation remained safe throughout construction. These solutions increased the overall project cost because of the additional excavation work, ground improvement, retaining structures, and monitoring systems. However, they were necessary to maintain safety and construction quality. Overall, these measures proved to be effective. They improved excavation stability, enhanced site safety, increased construction efficiency, and successfully supported the foundations and substructure works for the TRX development. And that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Muhammad Fazli. My metric numbers is 2024249182. So I will continue this presentation for the comparison of construction method between Merdeka 118 and Tun Razak Exchange, which is TRX. So firstly, for the primary excavation technique, Merdeka 118 used the top-down bulk excavation method, while TRX applied a stage excavation approach. This is because Merdeka 118 involved a deep basement near MRT tunnels, whereas TRX had a larger site area. For the key operational process, Merdeka 118 carried out excavation layer by layer with lateral support, while TRX focused on gradual earthwork to maintain ground stability. Next, the main constraint for Merdeka 118 was it limit site and nearby MRT lines, while TRX benefits from a larger 70 acres site. Lastly, Merdeka 118 required temporary retaining system for its 30-meter deep basement, whereas TRX focused on standard stage excavation for a large-scale development. So for overall, both projects selected different construction method based on their site condition and project requirements. Okay, next is the comparison of material. Both projects use high-strength concrete as the main structural material. However, Merdeka 118 also used heavy structural steel to support its deep excavation. For the piling system, Merdeka 118 use contiguous ball piles, while TRX use secant pile walls. For ground stabilization, Merdeka 118 use bentonite slurry, whereas TRX use grouting materials and soil stabilizer. In terms of the retaining system, Merdeka 118 use heavy I-beams and pre-stressed ground anchors, while TRX use standard retaining structures. Finally, TRX also use crushed aggregates, selected fill materials, and geotextile for fills and base materials, whilst this was not the main focus for Merdeka 118. Overall, the materials were selected according to the different ground condition and engineering requirements of each project. Okay, so lastly, the comparison of equipment. For drilling and piling, Merdeka 118 use heavy hydraulic rotary drilling rigs, while TRX use modern piling rigs. For rock breaking, Merdeka 118 required heavy crawler cranes because of the hard limestone, whereas TRX mainly use hydraulic breakers. For excavation and hauling, Merdeka 118 use standard and long reach excavators, while TRX use a larger fleet of excavators, wheel loaders, bulldozers, and dump trucks to support its large-scale earthwork. So overall, Merdeka 118 required more specialized equipment due to its challenging site condition, while TRX focus on higher productivity for a larger project area. That's all from me. Thank you.
Okay, so as you can see here, this table compares the cost components between the Merdeka 118 and TRX. So for the Merdeka 118, the main cost came from the specialized machinery, steel returning systems, equipment maintenance, and contiguous geotechnical monitoring because of the deep excavation and the nearby MRT tunnel. On the other hand, TRX focus more on the large-scale earthwork, secant pile walls, environmental protection, and structural monitoring due to its larger development area. So overall, both projects required high construction costs, but for different size conditions and engineering requirement.
Now let's go to the performance comparison for both projects. So the first one is structural stability. American MOS strictly limited retaining walls movement to protect an active nearby MRT station from damage. And for TRX, they use stages excavation and retaining structures to minimize ground movement and maintain stability. For groundwater control, Mereka 118 uses 24/7 pyrometer monitoring and dewatering to stabilize the water table and prevent soil cracking. While TRX successfully managed severe groundwater intrusion using robust dewatering system to ensure site safety. The third one is geological management. For Merdeka 118, it overcame swapping limestone, bedrock, and cavities using chiseling rigs and bentonite slurry to prevent borehole collapse. For TRX, there is unpredictable, irregular limestone formation through comprehensive geotechnical testing and continuous monitoring. For logistical and environmental, Mereka implemented a night shift hauling scheme that successfully reduced traffic congestion in downtown Kuala Lumpur. And for TRX, they utilized targeted traffic management plans and regular water spraying to minimize both dust emission and congestion. Next is the similarities and differences. In context of geological context, the similarity is both project face compressed Kuala Lumpur limestone formation featuring high groundwater levels and irregular rock cavities. The differences between both projects is Berikama 8 deals with a highly concentrated 30-meter depth pit, while TRX handle varying subsurface conditions spread across a 70-acre footprint. For urban constraint, both developments were situated in highly congested areas of the city center. There is required careful planning to avoid disrupting their surroundings. The differences is Mereka was severely restricted by a railway protection zone, whereas TRX faced broader environmental issues like dust and noise affecting nearby businesses. For earthwork execution, both successfully utilized heavy retaining structures and continuous real-time monitoring to ensure safe excavation practices. The differences is Barika 118 relied on top-down method which internal steel struts, while TRX utilized a stage excavation approach with secant pile walls. For site space and logistic, the similarities is both employed large fleets of excavators and heavy-duty dump trucks or transport massive volumes of excavated materials. The differences is Mereka 118 had no on-site storage space, forcing immediate off-site removal, while TRX faces logistical challenges primarily due to heavy surrounding traffic. Let us continue to the critical analysis of this project. So moving into our critical analysis, we identified four key takeaways from this mega project. First, tight urban constraint completely dictate design approach as seen with Merdeka 118's deep pit. Second, the massive 70-acre scale of TRX requires strict phase execution to manage environmental impacts. Third, standard borehole testing is simply inadequate for Kuala Lumpur's highly unpredictable limestone bedrock. Therefore, continuous real-time geotechnical monitoring is absolutely vital to ensure urban structural safety. Next is recommendation for improvement. The first one is comprehensive subsurface investigation. That is to carry out a study before mobilization using high-resolution geophysical surveys to map underground cave, bedrock slopes, and uneven formation. Second is advanced groundwater control. It is to deploy new technology dewatering machines with piezometers to control groundwater extraction and avoid dangerous drawdown impacts on neighboring soil and buildings. And the third one is smart logistical management. That is to implement high-end traffic and environmental software to control machinery and trucks that can minimize idling time, optimize internal RAM usage, and allowing tighter control of noise and dust emission.